Okay, so this is really important stuff. It's called the normal distribution, normal with a capital N because it's so important. It gets a capital letter. It's very easy to work it out. We start with the mean. And we use the standard deviation to determine the sections. Once you understand mean and know how to calculate the standard deviation, this is really easy. We will add percents using the empirical rule. The empirical rule is 68, 95, 99.7. And I'll explain those. This is a huge thing for stats. It's as important as the unit circle was to trigonometry for you guys last year, but a lot easier. So what this means is this is the mean right here, right? This is one standard deviation above the mean. This is two standard deviations above the mean. This is three standard deviations above the mean. Likewise, this is one standard deviation below the mean, two standard deviations below the mean, three standard deviations below the mean. And as it works out with many, many things like IQ scores, SAT scores, ACT scores, we find that the percent is the same. So 68%, if data is distributed normally, if it's a normal distribution, 68% of the population will fall within one standard deviation. So if 68 fall within one standard deviation, how many is that above and how many is that below? What's 68 divided by 2? So that'd be 34% are going to be a one standard deviation above the mean. 34% are going to be one standard deviation below the mean. Now our second number, 95, tells us that 95% of the population falls within two standard deviations of the mean. So this will help you kind of start to see the term standard deviation is abstract. You can tell me what it means, but do you really get it? This helps you start to see what the standard deviation does. Now, if this is 95%, right, what's left for these areas right here? We've already used 68% in the ones that I left white. So what's 95 minus 68? 27. So that means 27% fit in here, but half are above and half are below. So what does that leave for each side? 13.5. So that leaves 13.5%. 13.5%. Does that make sense so far? Does that blow your mind a little bit to know that if I were to pick up IQ scores, 95% of the population would be within two standard deviations? That's really cool. So now one more right here. 99.7. Now, how much is really left to go into these areas I colored purple? So we would say, well, we've already used up 95. So that's 4.7, right? Left to go right here. So what's 4.7 divided by 2? Half is here and half is here. What does that leave us? Okay, so now what does that leave us for more than 3? Well, we've used up 99.7, so that leaves 0.3 to be out here, but half is on the above, half is below. So what does that leave? Let me get another color for this golden area right there. What is each one of those? 0.15%. These are all percents. Let me add my percentages. Let's think about that for a minute. So if your IQ was up here more than 3 standard deviations from the mean, would you be usual or unusual? Is my golden area usual or unusual? It's unusual, like Einstein's IQ is going to be up in there, right? So actually, when we get anything outside of 3 is definitely unusual. And if you think about it, between 2 and 3, we're getting into the top 2.5%. That's not easy to do, right? Make sense? So let's do a practice problem with this, and then we'll think about it a little bit. So if I gave you an example, let's say example in a retirement community. An example in a retirement community. The mean is 77 years old, and the standard deviation is 2. And you all know how to find the mean. You could add them up and divide. You know how to find the standard deviation, punch it in. So now I want to know, if I randomly go select a person, what's the probability? This is a probability distribution, right? We're looking at probabilities, percentages. What percent of people fall between 73 and 79 years old? Basically, I'm saying, what's the probability that the person I pick is between 73 and 79, right? So I would go figure this out. I would say the mean is 77. Now, if the standard deviation is 2, I'm going to add 2, add 2, add 2. So that's what, 79, 81, 83. And then right here, I'm going to say 77 minus 2, minus 2, minus 2. So if this is my data, then I know that 99.7% of the people here are between the ages of 71 and 83. So if someone were 95, that would be unusual, right? Yeah. So what percent are between 73 and 79? That's from here to here. Well, from 75 to 79 is what? 68%. Those are my white blocks. And then this one is 13.5. 81.5. So this tells me that 81.5% of the people in this community are between the ages of 73 and 79. Does that make sense? Okay, let's do some practice with this to make sure we understand it, right? So this, I put one up there for you. You have one that you just made that you can look at. So assume a generator produces voltage amounts with a mean of 125 and a standard deviation of 0.3. So what I would do, anytime I've got a problem, right, I would do, we want to write down the mean in the center. Right? And now if the standard deviation is 0.3, I'm going to add 0.3, add 0.3, add 0.3, and I'm going to subtract 0.3, subtract 0.3, subtract 0.3, right? So what is that? What do you get when you add 0.3? Yes, right? So 125.3, 125.6, 125.9, and that's 1, 2, 3 standard deviations, right? Then we'll subtract, and what's that going to be? 124.7, 124.4, 124.1. This is our mean right there. We always check 3 standard deviations. That arithmetic is very easy, right? Let me bring that in further. There we go. That arithmetic is easy, yes? You just add on 3 times, subtract 3 times. So now, once we have our little graph labeled, it's very easy to answer questions. What is the approximate percentage of voltage amounts? Okay, so for A, between 124 and 125.6. How much is that? Well, this much is what? 68? Plus this little bit, how much is that little bit? 13.5, right? So what percent are between, wait, did I read that right? 124, oh, I read that wrong. Sorry, y'all. 124.4 and 125.6. So what's that percentage if it goes from here to here? 95%. I don't know what I was looking at. Okay, 124.1 and 125.9. That's here to here. What's that percent? Right? Now, if we do one that's off a little bit, which percent is below 124.4? So that would be this. How can I figure that out? I can add up this side, right? And how much is that? What's left for these last two? 2.5. What percentage is greater than 125.9? That's bigger than 3 standard deviations. And what's that amount? 0.15%. That makes sense how you can read those? Okay, let's try another one. Suppose scores on a test are normally distributed with a mean of 80 and a standard deviation of 7. So what are our numbers going to be? 80, that's our mean, right? 87 plus 7 is 94, plus 7 is 101. 80 minus 7 is 73, minus 7 is 66, minus 7 is 59. So this is my mean, right? And then it may help you to put your little, I like different colors. Of course, right there would be the very end. So what percent scored less than 87? There's 2 ways I could do this. I could add each individual piece up, right? But let's think about something. If I'm including, this says less than 87, that's right there. From the orange on is 50%, right? So can I just say it would be this 50% plus this in here, which is how much? 34%, which is how much? 84. And these are percentages. This is a density distribution, it's a percent. So when we look at this chart and we're figuring out, you're figuring out what part of the population would fit into what you're looking for. So for this test, what percent scored less than 73? Here's 73. So I could either say 84, 100 minus 84, because that would be 84. Or I can add these little parts up. Either way, what do you get? 16%. Okay, what percent scored more than 94? So that's 2 and 3 standard deviations. And what do 2 and 3 add up to? 2.5. And 2.5, oh, now they gave us the percent and they want us to tell the score. 2.5 scored less than what value? Well, 2.5 is how much? That's less than 2 standard deviations, right? So that would be what? The 66 cutoff, right? So 2.5% scored less than 66. Does that make sense? And I didn't write them all in here. Let's review it. This is what? 34%, 34%. What percent was in the next block? And this you're pulling off of your sheet that you made, or basically out of memory. What went in here? And in here? I would write those down until I knew them well when I did little examples. Now, if I were to ask you, is it unusual to be more than 3 standard deviations away from the mean, above or below? Would you say, yes, that's unusual? That's only 0.15%. That's unusual. If we were looking at IQ scores, Einstein would probably be up there, right? Way off the charts. We're still a little unusual when we look at bigger than 2 standard deviations, because to be greater than 2 standard deviations, that's only 2.5% of the population, correct? Is it hard to be in the top 2.5%? Is that tough? It's kind of tough, right? You're getting kind of unusual when you get there. So does that make sense? Okay, so I'm going to give you time to finish. There's a few problems, no more than you can get. You could get them done now. So let's go.